Hey guys, so this is going to be part 2 of the series that I'm going to be doing for you guys. So today we're going to be looking over or reviewing what we learned 2 days ago. So yeah, let's get started. Okay. So we're going to go back to our operator control.h file. So the one thing that I want to start off with is that we're going to start off with something called header guards. So header guards are basically something that you use when you have a lot of header files that go in different CVP files. So what header guards do is they prevent you from initializing your .h file somewhere twice. So what happens is if you don't have header files, what happened is some places it would define your definitions that you had in the .h file twice, which would cause compilation errors, which you don't really want. So the way to fix this is you use header files. So the way to do header files is you would do hashtag fndefine, then you would do op on caps operator control and then _h. Then you would do hashtag define and then the same thing again, and then you would end it with a end statement like that. So this is how and this should go away soon, but this is how you do header guards. So header guards are very important, and you should do it for every single header file. I say for every header file that you make, for autons, for something else, I suggest that you try, or not try, you use header guards, sorry. So now what we did was we learned intake controls. So as we all remember, we need to start with initializing the function in our .h file. So we would say void intake control and then void. Okay. Initialize it, and let's just build it for now. Alright, now that we have built it, since it's saved, we're going to go to our operator control. We're going to say void, or better yet, why don't we just copy and paste this so we don't lose any, so we don't accidentally make a mistake in naming it. You don't really need this void. And let's start. Before that though, we need to put in the motors. So let's say we add a device. So motor port 19. Let's say our intakes are 600 RPM. Oops, I forgot to change the name. So we're going to change this to intake left. And then we're going to do another motor, and that's going to be port 15. And we're going to call this intake right. This is also 600 RPM. So just to check, we go to robot configuration. We see that both intake left and intake right are there, and they're classified ports with the ratio 6:1, showing that it's 600 RPM. So we're going to go back to operator control, get this out of our way, and let's get started. So basically, as I said before, you want to, so drivers usually, when they're driving, usually have their finger thumbs on both of the joysticks, and they don't really want to take their thumbs off, otherwise it would be really inefficient. So what most people do is, for intake, since they're really useful while driving, is they use it on the shoulder keys. So what we want to do is, when we look at the controllers that are labeled, left has L1, L2, right side has R1, R2. So for our case, we want our driver to have it on his right side. So we're going to have an if statement, which says if controller1 dot button R1 is pressing, so this API, which is basically something that VEX gives us, checks if the button is pressing, then this is gonna occur. So this if statement will occur. So if that is pressing, that means our intake left, we will say, will spin forward at 100, %. Then we'll do the same for the right side. I'll do R and take R, that's spin, forward, 100%. And then, so now what this will do is if your driver presses the top button, it will spin at full speed in the forward direction. But that's only intaking. We also want to be able to outtake. So the way to be able to do outtake is we'll have an else if statement, and we'll say else if controller1 dot button R2 is pressing, which is the same. It's the API that checks to see if the button is being pressed or not, which VEX precodes. We're going to take this, copy and paste, but instead we're going to make this reverse because we want to turn in the reverse direction. And I remember I told you guys that if you just put a negative sign, it will do the same thing as reverse, but whatever you guys feel most comfortable with. Usually I interchange between them both. I really don't have a preference. So let's say that we're done. We want to test this code, so we're going to build it. So now that there's no compiling errors, we're going to go back to our main CPP, and right underneath our joystick control, we're going to say intake control, and then we're going to build it, and let's say I'm connected to my robot. So this downloads to the robot. What happens now? So when you start the program and you start intaking, what happens is if you press R1, for instance, it will continuously intake. Even if you take your finger off, what should happen though is that it should stop. But because we don't have an else if, and when we press it, it just continuously spins. It doesn't ever stop. And why does that happen? So we try pressing button R2 to see if it outtakes. Okay, that works. It starts outtaking, but it still doesn't stop. But why? Because this is in a while loop, so it's continuously just going to keep running. There's no command for it to say, okay, you need to stop right now. So the code just thinks, okay, I just want to continuously spin. There's nothing else to it. But you need a code that says, okay, if I'm not pressing either buttons, then I need to stop the motor. So what we do is we go back and we say, okay, how do I do that? And you're like, oh, I forgot an else statement. So we're going to do else. We're going to say else intake left dot stop and intake right dot stop. So what this does is now that let's say we compile it and we download it to the robot. So what this does is now when we take our finger off, we see, oh, finally it stops because of this else statement, because it checks the if statement and it says, no, that's not pressing. Then it checks the else if statement and it's like, oh, nope, that's not working either. And then it goes to the else statement and says, okay, that means I just have to stop the motor. And there are multiple types of a stop feature. So there's a hold function, there's a break function, and there's a coast function. So let me go in depth about both. So hold function, usually what it does is it's something where VEX themselves have created a PID that they tune by themselves. So what it does is when you call the hold function, it stops the motor and it sets a PID to keep it at that certain position. So let's say you try to move the motor, the intake, whatever you want to move. So what it will try to do is it will try to fight against the force that you're trying to move it with and try to keep it in the same position that it is at right now. So that's really efficient for something like, let's say, when you're coding a ton of those functions, it's really helpful for when you're trying to stop and then turn, let's say, for example. It's really helpful because it makes sure you don't coast or drift. The other function is break function. So what the break function basically does is it's like hold, but it's weaker. There's no PID that's trying to fight against you. The only thing that it tries to do is it tries to counteract motion. It doesn't try to come back to its original motion or trying to fight against you. It's just trying to keep it in place. It's not trying to constantly adjust to the forces and trying to adjust and apply force in that certain direction. And coast is basically, let's say, it turns off the motor, but if unlike brake and hold, when you move or try to move the motor, it will freely move with you. There's nothing trying to counteract against your movement, unlike brake or hold. So usually what people do is, because you have a brake or hold function in autonomous, what people do is before before the joystick driving controls happen, you usually set the motors back to coast, because if you don't, some issues that occur is when your driver takes his fingers off, for example, to stop, your intuition would be that it would start coasting. But because it's already on a brake type hold, what will happen is it would immediately stop and it would jerk, which most drivers are not used to, and it's uncomfortable, which we will go over in later lessons. But for now, let's say that's not an issue. So for intakes, most people usually use brake. So I'm going to say intake left, stop at brake, and brake. And that's it. Now we're going to build. There's no compiling errors. And let's just make this look a little bit cleaner. That's it. So if you have any questions, and let's also say that when we start coding, one is going in the reverse direction. So let's say the left motor is going in the different direction. We'll just go back in here and we'll click this, and then done. And now it works. So that's about it for today. If you have any questions, feel free to ping me in the Discord channel. And yeah, I hope this helps. See you guys.